Let's compare the difference between descriptive statistics and inferential statistics. Most important thing at the most basic level is to keep the concepts organized. What concepts are associated with descriptive statistics, which important concepts are associated with inferential statistics. So for the most part, with descriptive statistics, we have measures of central tendency, the three M's, measures of variation, standard deviation, and range. Now, inferential statistics is a little bit different. Unlike descriptive statistics, in which we're trying to organize and find patterns in our data that can help us make sense of that data, like finding an average score or the standard deviation, how much the scores vary from the mean. All of that can be very helpful in making sense of our data. Inferential statistics takes some of that and then uses its own specific statistics to try to actually help us see if we can generalize the findings to the broader population. But more importantly, before we can even generalize, we have to figure out if we did notice differences between the two groups experimental and control, were those differences significant enough that we can reduce the role that chance played in the differences between those the two groups. Because remember, even without being exposed to the independent variable, we're going to see variation between animals and humans just naturally, right? And there are other issues of chance, but that's all we really need to know in terms of chance at this point. So what gets confusing with students, I think, is this concept called statistical significance, because it is both a statement of, but also something that can be calculated. So just like standard deviation tells us how much the scores vary from the mean, but we do a calculation, right, to get standard deviation. And you can see that in Myers, and I took you through that in class. Statistical significance, we actually do tests. And some of those tests are a t-test, that should be lowercase, by the way, chi-square, ANOVAs, there's an f-test. All of those tests give us something called a p-value. Probability value. And what the p-value is, oh, excuse me, my voice just cracked. What the p-value is literally, it measures chance, right? To what degree did chance play a role in our results between the two groups, right? Because we're always comparing the experimental and the control group. Okay, so so we do some calculations. So again, statistical significance, we calculate it. Then the second part of statistical significance is we turn that into a statement. And the statement is really going to tell us about whether or not the differences between the groups was a significant difference or not a significant difference, right? Because you can either, once you get a p-value, we can either say our results were statistically significant or they were not statistically significant. So basically, there's a cutoff, just like there is in school for passing a test. You have to get a 60% or above. Well, in inferential statistics, there are some exceptions to this, but for the cutoff is you have to have probability of 5% or less. You'll often see it as probability less than 0.05. Okay, but it's usually 5% or less. So meaning if we do one of these tests, which you're not responsible for doing, and we get a p-value of 0.2, the 2% tells us that is the role chance played in the differences we observed in our dependent variable, right? Then we can infer. So this is the second part. We can infer, because the p-value measures chance, we can infer that our independent variable is 98% responsible for the changes we observed in our dependent variable. Okay? So that's all it says. It basically says that the changes we saw between the two groups, that the independent variable probably played a 98% role. That's an inference from the p-value. The p-value itself is a measure of chance. Okay, so if we had a p-value of 0.07, that would be 7%. We don't make the cutoff. It's like getting a 58% on an exam or something like that. Okay, that's just too high of a role for chance to play. So those results would not be statistically significant. So those are your basics. I'm going to do a part 2 on inferential statistics